Today I am going to discuss about data models. In last class, introduction to database management system, what is meant by data, what is meant by database, what is meant by database management system, what are the advantages and disadvantages of database management system over a file system, and then applications of database management system. Okay, in this class, that is different types of data models, right? First one is a relational model. A relational model. Second one is the ER model. Third one is the network model. Fourth one is the hierarchical model. But according to, academic or gate point of view, that is a relational model and ER model plays a very important role. Okay, what is meant by relational model? Before going to the relational model, RDBMS. What is the RDBMS stands for? A relational database management system. A relational database management system. A relational DBMS. What is the actual definition of RDBMS? RDBMS is a software that facilitates the end user to manage underlying the relational database. A relational database. Underline what? A relational database. A relational database. And then what is meant by relation? Relation is in the form of tables. Relation is in the form of tables. Whereas the relational database management system, that is a what type of softwares are used here? That is a Oracle, Sybase, SQL, MS Access, etc. These are the examples of relational database management system. Okay, relation is nothing but is in the form of table. Each table having, that is a rows and columns. Rows and columns. Observe here, this is in the form of table, that is a student table. Student table having student ID, student name, percentage, address. Clear? This is the first row, second row, third row, fourth row, fifth row. That is a row 1, row 2, row 3, row 4, row 5, rows and columns. That is a unique rows and unique column. Is nothing but that is a relation, is in the form of table. One table related to the another table is nothing but relationship. Observe here, what is the first one is a, first one is really, second one is a tuple or tuple. What is meant by tuple? A tuple is nothing but a row in a table is nothing but tuple. That is a tuple 1, tuple 2 or tuple 2, tuple 3, tuple 4, tuple 5. Right, a row in a table is nothing but tuple or row. What is next here? Column, SID, you can call as attribute. Attribute 1, attribute 2, attribute 3, attribute 4. Or columns, that is the first column, second column, third column, fourth column, or first attribute, second attribute, third attribute, fourth attribute. That is a number of tuples. Number of tuples is nothing but cardinality. Cardinality. Number of tuples is nothing but cardinality. Number of attributes or number of columns is nothing but degree. Is nothing but degree. Okay, what is the degree of student table? Here 4. Degree of student equal to 4. Degree of student table equal to 4. Whereas the cardinality of student table, what is the here cardinality? 1, 2, 3, 4, 5. That is a 5. Cardinality of student table equal to 5. Okay, and then observe here SID, S name, percentage, address. And what is a SID? SID is a primary key. SID is a primary key. Primary key. what is meant by primary key? Uniquely identified within the entity set is nothing but primary key. That's why student ID is a primary key. Before going to that, suppose student name, percentage, address. We know student name. Can you identify the all records? We know Raju. Can you identify the all records? No. We know percentage. Can you identify the SID, S name, address? No. When we know address, can you identify the all records? No. Why? Because we know student name. Can you identify the all records? No. Why? Because same name appears twice. Raju, Raju. Okay. That is a redundancy is there. That's why here SID is a primary key. Before going to the primary key, first what is meant by super key? What is meant by super key? What is meant by super key? Super key is nothing but definition, an attribute or set of attribute that has uniqueness property is nothing but super key. An attribute or set of attribute that has uniqueness property is nothing but super key. For example, simple example, a relation A, B, C, D are of A, B, C, D. R is the relation. I mean A, B, C, D are the columns. That is a tends to B. I mean B tends to C. I mean C tends to D. A tends to B and then B tends to C and then C tends to D. C tends to D. These are all functional dependencies. Suppose A closer equal to, what is the A derives what? B. B derives what? C. C derives what? D. AB closer, we can get A, B, C, D. Observe here, we can get original relation. That's why A is a super key. A is a super key. An attribute or set of attribute that has uniqueness property is nothing but super key. That is the A closer. Suppose AB closer. Observe here AB closer. AB, simply we can write as AB. AB derives what? I mean A derives B, B derives what? C. I mean C derives what? D. That is a AB closer. We can get the original relation. That is a B, C, D. That is AB is a super key. And then ABC closer. That is a ABC closer. What is a ABC? Simply we can write as first ABC. And then A derives B, B derives C, and then C derives what? That is a D. That's why ABC is a super key. ABC is a super key. And then last one, ABCD closer. What is the ABCD closer? We can get ABCD. Okay, we can get the original relation. ABCD also super key. What is my super key? An attribute or set of attribute that has uniqueness property is nothing but super key. Observe here in our table SID, S name, percentage, address. SID is a super key. But combination of SID, S name also super key. And then combination of SID, S name, percentage also super key. And then SID, S name, percentage, address is also a super key. Okay, is a combination. That's why here, I mean A closer, we can get the original relation. AB closer, we can get the original relation. ABC closer, we can get the original relation. And then ABCD closer also, we can get the original relation. Here A, AB, ABCD. I mean, what is that? A and then AB and then ABC, ABCD is a super key. Among all, I mean, 4 super keys, what is the minimal here? Minimal here, A. What is the minimal here? A, AB, ABCD, ABC, ABCD. What is the common? A. That's why A is a key. What is a is a key? What is the key definition? An attribute or set of attribute that has uniqueness property with minimality. What is the minimality? A, AB, ABC, ABCD. What is the minimal? Minimal is the A. Okay, that is the key. Okay, right? And in relational model, what is by relation? And what is my tuple? What is my degree? What is my cardinality? What is my super key? And what is my key? And what is my primary key? Primary key is a SID, student ID is the primary key. Why? Because we know student name. Can you identify all records? No. Why? Because same name appears twice. Okay. We know percentage. Can you identify the remaining records? No. Why? Because same percentage twice can appear. Suppose we know address. Can you identify all records? No. That's why we know student ID. We can easily identify it within the records. That's why student ID is a primary key. That is nothing but first model, relational model. Relational model is in the form of relations. Relation is nothing but table. Table having unique rows and unique columns. That is our first model, relational model. Whereas the second model is the ER model. Entity relationship model. ER model. ER model. And what is meant by entity? What is meant by entity? What is meant by attribute? And what is meant by a relationship? ER model. What is the main purpose of ER model? Pictorial representation of the form. Pictorial representation. Pictorial representation of the form. For example, here customer, and what is here? Rectangle can represent entity. A rectangle can represent entity. Entity is a thing or name. Entity is a thing or object. Entity is a thing or object. And what is a diamond? Diamond can represent relationship between the two entities. Diamond can represent a relationship between two entities. Between two entities. And whereas in the here, that is the line, single line can represent partial participation. Partial participation. And then double line can represent total participation. Total participation. What is a ER model? Entity relationship model. It can represent, that is a pictorial representation of the form. Example, customer. Customer is a entity. And what is here? Phone number, customer name, customer ID, customer city. These are all attributes. Attributes. What is meant by attribute? What is meant by attribute? Characteristics of entity set. Characteristics of entity set. Characteristics of entity set is nothing but attribute. Phone number is a attribute, customer name is a attribute, customer ID is a attribute, city is a attribute, here loan number is a attribute, amount is a attribute. That is the attribute. And then next one, attribute, different types of attributes. First one is a simple attribute. Simple attribute. Simple attribute. The attribute cannot be divided into subparts. Is nothing but simple attribute. Example, roll number. Example, roll number. Cannot be divided into subparts. And then second one is a composite attribute. Composite attribute. Composite attribute. I mean, the attribute can be divided into subparts. For example, that is a, customer name. Customer name, that is a first name. Divided into subparts. First name. Next middle name. Middle name. And then last name. Is nothing but what? Composite attribute. Simple attribute, composite attribute. And then third one is a single valued attribute. Single valid. Single valid attribute. What is meant by single valid attribute? An attribute having only one value is nothing but single valid attribute. Same, that is a roll number is an example of single valid attribute. And then fourth one is a multi-valid attribute. Multi-valid attribute. Multi-valid attribute. Multi-valid attribute is nothing but more than one attribute is nothing but a multi-valid attribute. Representation like that only. This is the multi-valid attribute. An employee or customer may have one or more phone numbers is nothing but multi-valid attribute. Right, next one, derived attribute. Derived attribute. Derived attribute. That is a derived attribute. Is example, age. Age can be derived from date of birth. Age can be derived from date of birth. And what is here? Age is the derived attribute. Age is the derived attribute representation like that only. And then DOB is the stored attribute. Date of birth is the stored attribute. Stored attribute. Okay, that is what is meant by attribute. Characteristics of entity set is nothing but attribute, simple attribute, composite attribute, single valid attribute, multi-valid attribute, a derived attribute. Okay, that is nothing but attribute. That is the first one is the entity. What is meant by entity? Entity is a thing or object. That is a representation like that only. Rectangle can represent, entity. Attribute. What is the attribute? Ellipse can represent the attribute. Ellipse can represent attribute. Attribute. That is a double line. Total participation. All values in entity set within the attribute is nothing but that is a total participation. And single line is a partial participation. And what is the derived attribute is a dotted ellipse can represent the derived attribute. And what is the primary key? What is the primary key? CID with underline. Here observe here customer ID is a primary key. Primary key. What is meant by primary key? Uniquely identified within the entity set is nothing but that is a primary key. That is nothing but that is a ER model or ER diagram. ER model can represent pictorial representation of the form. That is nothing but ER diagram. Observe here that is a one example. Gate point of view example here. Observe that this is the M is a entity. Entity can represent what? That is a rectangle can represent entity. Attributes M1, M2, M3. That is a diamond can represent relationship between the two entity sets. That is R1 is the relation. And then P is the entity having that is the attributes P1, P2. Here that is a total participation. This is a total participation. And then N is the entity, N having that is a N1 and N2. And what is a here that is a dotted thick line is a primary key, and this is the this is the partial key. That is a dotted line represent that is a partial key. That is a weak entity. Why? Because double entity is nothing but weak entity. There is no present in the key in a entity set is nothing but weak entity. And what is by strong entity? This is a strong entity. M1 is a key that is a present in the primary key in our table is nothing but strong entity. Observe here what is the actual question. The minimum number of tables needed to represent M and then N and then P comma R1 comma R2 is, and how many number of tables? Observe here how many number of tables. What is the first relation? That is the first one. First we represent that is the M, and then here that is a diamond can represent the relationship between the two entities, that is the R1. And what is the here? That is a that is a P. P is the one entity. Okay, observe here. And what is here? Total participation. This is a partial participation. That is a this is the what is the here with line? That is a single line is the many, and then arrow with line with arrow is the that is one. That's why here that is a many to one relationship. The many to one relationship. But here simple trick is there. What is a simple trick is there or trick point? And what is the here many to one? Here many side we merge the values. That is a M R1. That is a M R1. And then that is a 1. And the next one is a that is a P. Second one is a P. Second one is a P. And what is the here? 1 and then 2. 2 tables. What about that is a remaining side? Remaining side. What is the remaining side? P tends to. That is a P tends to. That is a representation what? R2. Diamond can represent the relations between the two entities. And what is here? Total participation. That is all values participated in a entity set within attribute. Okay. This is the second side. what is that relation here? I mean 1, here many. And what is the here? 1 to many. 1 to many is the, we merge, that is the tables in this side. Whereas in this portion, we merge in this side. What is the here? MR1, that is a one table or one relation. And then here, and what is that here? N. I mean, that is a MR1 is a one table. And then NR2. NR2 is the another relation. And then third one is the, that is a P. And what is the, how many tables? This is a one table. This is the second table and this is the third table. Total tables is a 3. The answer is 3. The answer is a 3. That is the minimum number of tables needed to represent M, N, P, R1, R2 is, and what is the how many tables? 3 tables. That is the, I mean, GATE previous question based on the ER diagram, entity relationship diagram. Clear? That is the next example. One more example. That is, let E1 and E2 be the two entities in an ER diagram with single valued attribute. R1 and R2 are the two relationship between E1 and E2, where R1 is the one to many and R2 is the many to many, and R1 or R2 do not have any single attributes of their own. What is the minimum number of tables required to represent this situation in relational model? In relational model, based on the ER diagram, second, I mean, GATE question, previous question. And what is the first? Let E1 and E2, two entities. E1, E2. Entity is nothing but thing or object. That is the E1 and E2. Two entities. That is the E1 and E2 to be two entities and ER diagram with single valued attribute. Attributes is a single valued attribute. And whereas in the R1 and R2 are two relationship between E1 and E2, where R1 is one to many, where R1 is one to many relationship. One to many. Many is the total participation. One to many relationship. Where R1 is the one to many. And R2 is many to many. R2. That is the second. Diamond can represent the relationship between the two entities. R2 can represent, that is a, I mean, many to many relationship. I mean, many to many. Many to many relationship. Okay. Many to many relationship. What is the minimum number of tables required to represent this situation in relational model? What is meant by relational model? One table can be related to the another table. That is a one to one, one to many to one, many to many relationship. Okay. Here we concentrate on, I mean, many to one or one to many. Many to one. Many to one. We merge, I mean, many side. Whereas in the many to many, we can't merge. Many to many is the, we cannot merge. For example, this is a many to many relationship. Many to many relationship. Many to many relationship. This is one table. I mean, this is the second table. And this is the third table. We cannot merge. Whereas in the many to one, there is a merge many side. Observe in previous example also. Based on the technique, and what is the first one? What is the first relation? E1. What is the first one? E1. I mean, entity 1. That is a diamond can represent a relationship between the two tables. That is a R1 and then E2. E2. What is that? One to many relationship. What is that? Previous tricky technique? That is a many side. We merge the table many side. What is that table? Is the E2R1. E2R1. That is one table. Is it clear? Why? Because one to many relationship we merge. That is a many side. That is a tricky technique. That's why E2R1. Okay. And then here that is a E1. One more is the E1. Okay. And what is the other side? What is the other side? Many to many. Many to many. That's why that's why observe here, that is a, this technique is the E2R1. E2R1 diamond can represent the relationship between the two tables. That is the R2. Okay, clearly you can write in this side, that is a, I mean, entity ER2, and then here that is a R2 diamond can represent relationship between the two tables. and then what is that here? E1. What is that here? E1. What is that here? Here E1. E1. And what is that here? We cannot merge. Why? Because this relationship is a many to many. Many to many. E1 is one table. I mean, relation R2 is the one table. I mean, ER2 is the another table. Total tables is the number of tables 1, 2, 3. Add 1, 2, 3. That's why. What is that answer? Answer is the first one. That is the minimum. I mean, this situation in the relational model, how many tables needed? That is the 3 tables are needed. That is the ER model, entity relationship model. We conclude that data models, different types of data models, relational model, network model, hierarchical model. Okay, in this model, I mean, 2 models plays a very important role. That is the relational model and then ER model. Relational model is in the form of relations. Relation is in the form of table. Each table having unique row and unique column. What is meant by tuple? Tuple is nothing but a row in a table is nothing but tuple. What is meant by cardinality? Number of tuples is nothing but cardinality. What is meant by degree? Number of attributes is nothing but a degree. And what is meant by domain? What is meant by primary key? What is meant by super key? What is meant by candidate key? Okay, what is meant by super key? What is meant by super key? That is a simple another example, one more example. R of, I mean A, B, C. That is A tends to B and then B tends to C. And what is here relation A, B, C? A tends to B, B tends to C. A closer. A derives what? B. I mean B derives what? C. A is a super key. A is a super key. And then B closer. What is a B closer? B closer. B closer is the only we derive BC. B is not a super key. That's why combination. What is the AB closer? What is the AB closer is the ABC. AB is a super key. ABC closer. You can get the original relation ABC. That is a super key. And what is in the primary key? Okay, you need not bother about there is a foreign key that we will see in the further classes. That is a relational model. Whereas the ER diagram is nothing but that is in the form of pictorial representation form. That is I mean entity relationship model. What is in by entity? What is in by relation? Okay, what is in by relationship? Relationship is nothing but one table is related to the another table. That is a one-to-one relationship, one-to-many, many-to-one, many-to-many relationship. Okay, and then next one is the attribute. What is by attribute? Simple attribute, composite attribute, multivariate attribute, derived attribute, and then 2 gate examples, simple examples. Today we'll stop here. In next class we'll discuss about that is remain things. Thank you.